So let's look at some examples of this. Okay, you are most definitely going to see problems like this on test 3, but also the final exam, because we really want to see if you know how to handle logs or not. So we have log base 5 of x plus log base 5 of 4x minus 1. So this is definitely a log equation, right? It's got some logs, it has an equal sign, that makes it a log equation. All right, so the first thing is you need to decide which of the 3 rules you're going to use, okay? And your hint is what I circled there, right? Which of the 3 rules involves addition? Do y'all remember? The multiplication rule, which is called the what? Product rule, right? So we're going to combine these using the product rule. What if it would have been a subtraction? What rule would we have used instead? Quotient rule. Okay, so we're going to combine using the product rule. So we're going to do the log base 5 of x times 4x minus 1. In other words, we're condensing it down into one log term using product rule. So ignore the logs for this part, right? Now you just need to use distributive property. So you're going to get the log base 5 of 4x squared minus x equals 1. So notice we did step 1, right? So what's step 2 say to do now? Now we need to make sure we can rewrite this, okay? That's why I put a star by this step. It is arguably the most important step here, okay? So what I mean by rewrite is you need to rewrite it in a form that we're more comfortable with, right? I think we can agree we don't love log form, right? So let's get it out of log form, okay? So how would I rewrite it? 5, right, that would be the base, raised to the first power equals what we're taking the log of. So why is this better than what we started off with? What does it not have in it anymore? No more logs, right? So now we just need to solve it like an x squared equation. So I'm going to move 5 to both sides, or to the other side, I mean, because I need to have x squared equations equal to 0. So right here, I'm either going to factor or I'm going to use quadratic formula. So we have reviewed factoring several times this semester, so I'm not going to go back and show you AC method. We should be on the same page with that at this point. If you're still a little shaky on factoring, remember there's lots of tools out there. But if you use AC method, you'll get this. So I'm just going to write AC method so that you can look it up on your own if you need to. Okay, so now what? Now that I have it factored, what do I do with each of those parts? Set each of those parts equal to what? 0? So I end up getting what looks like 2 answers, but then I need to remember that I'm actually talking about logs. Okay? So the log of 5/4 isn't a problem because it's a whole number, or sorry, not a whole number, it's a fraction, but it's a positive number. But which one's not going to work? When you go back to try to check it, what's going to happen when you plug in a -1 right there? It's not going to work, right? So this one's invalid, and it's invalid because we can't have logs of what kind of numbers? Negative numbers. Okay, so in the end, the only answer that you would kind of accept moving forward would be the 5/4. Okay, now you're not going to be able to check this one easily on your calculator. Why do I say that? Why can't you check this one easily on your calculator? You can if you can figure out how to change the base on your calculator, which there is a way in the math menu. But why is it not going to be easy to check it? What's the understood base on your calculator? It's not 5. What is it? 10. Okay, so just be aware that if you try to check these on the calculator, it's not going to work perfectly unless you figure out how to change the base. All right, so let's do some more like those. Okay, I really feel like this is really going to have you step it up and check to see, do you understand logs well, or were you just kind of going through the motions? right, so the first rule is I want to combine these, right? So what am I going to combine? What rule am I going to use to combine since I'm adding? Just like the last one. Product. So product rule says that we keep the base the same, but we can multiply the two things we're finding the log of. So I'm going to put brackets around this. So ignore the log for now. What do we need to do to simplify this? We need to do FOIL, right? We need to figure out what x plus 6 times x plus 4 is, okay? So we end up getting, if you do all the steps of FOIL, you'll get x squared plus 10x plus 24. I'll let you do the FOILing just to verify that you got it. So now we have the most important step, okay? What did I tell you the most important step is next? Now that we have it as a single log, right? Now we rewrite it. So how do we rewrite it? It's base to the first power equals what we were taking the log of. And then again, the beauty of this is now we're not really thinking about logs anymore. We're just worried about being able to factor this. We're not ready to factor, remember, until we are set equal to 0. So subtract 3 from both sides and we'll get x squared plus 10x plus 21. So I gave you one that I thought would be a little nicer to factor on this one. What are the factors of 21 that would add up to 10? 7 and 3? So when you set each of these equal to 0, notice you get -7 and -3. And then you go back up to the top and check. By the way, it's not just the fact that it's negative that makes it wrong. It's if you plug it in and you're taking the log of a negative, that doesn't work, right? So notice when you plug in -7, look up here where I'm pointing, are you going to be taking the log of a negative if you plug in -7? If you plug in -7 here, what will you get? What's -7 plus 6? -1, right? So this one's out. Okay, this one's invalid. Okay, again, we can't take the log of a negative. But I'd like to bring up a point that this one's actually okay. Even though it's negative, why is this one okay? Because when you go to plug it in, what's -3 plus 6? It's not a negative, right? It's just 3, and that's fine, right? I can take the log of a positive number. If you plug in -3 here, you get 1, and that's also fine, right? So it's not the fact that it's negative that kicks it out, it's what? When you plug it in, if the log is negative that kicks it out, okay? So this one is okay when plugged in. So I wanted to do one that maybe looked like it would be the same as the one before, but it's actually really not.
So if you get a negative, then you need to plug them in. You just always just check.
Yeah, that's why I underlined that step with these logs. Yeah, you just always want to check with these because they just have a history of kind of not working all the time. All right, so let's do maybe a quotient rule one. So what about this one? The log of x plus 4 minus the log of 2 equals the log of 5x plus 1. So the first thing is I do need to switch rules, and how do I know that? Because we're subtracting. So I'm going to combine using the quotient rule. So rather than multiplying, it's going to look like this. The log of x plus 4 over 2 divided by 2 equals the log of 5x plus 1. So notice this one's not like the previous two, not just because we're using quotient rule, but also because there's a log over here, okay? But notice the bases are already the same. So if the bases are already the same, what can we set equal to each other? the x plus 4 over 2 must be the same as the 5x plus 1. The point is we wanted it out of log form, and notice we have it out of log form now. So let me rewrite this over 1 and see if we remember. We already did this once today. So what rule do we need to use to go ahead and solve this now that it's out of log form? Cross multiply. So you're going to do this times this equals that times that. So we've got 2 times 5x plus 1 equals 1 times x plus 4. Make sure you distributive property here, although here you don't have to, right? 1 times something is just itself. So we get 10x plus 2 equals x plus 4. And then we're almost there. We just need to find out what x is. So we'll subtract x from both sides. We'll move the 2 over to the other side. So it's going to give us 9x equals 2. So then divide both sides by 9 if we want to know what x is. So x is 2/9. Okay, before I circle it, let's make sure that wouldn't give us a problem, right? If you plug in 2/9, you're not going to get a negative here, right? You're going to get something weird, but it's not a negative. And if you plug in 2/9 there, you're not going to get a negative, so this is legit. Notice the check step, I'm just trying to make sure I don't get something I'm not allowed to have. Okay, you're not really necessarily checking it for accuracy. You're just checking to make sure that it isn't something that you're not allowed to have. Okay, so let's do one more. And then at the beginning of the class next time, we might touch on some other ones before we move on to the new section. This is a really lengthy section, but a really, really important one too. So the first thing that is helpful, we want to be able to combine these two, so I need them to be together on one side. So I'm going to subtract the whole thing. It's all really one piece. So I'm going to have the log base 6 of 7x minus 2 minus the log base 6 of x plus 5 on one side, and then 1 on the other side. And the reason I want that is because I want to be able to combine these, right? Which rule do I use again? What rule would I use if I'm subtracting? Quotient rule, right? Notice this one looks just a bit different, so we're going to get the log base 6 of 7x minus 2 over x plus 5 equals 1. So don't forget this step. Anytime you have a log equal to a number, rewrite it. Okay? And how you rewrite it is base to the answer power equals the other thing. So I'm going to rewrite this over here. This is essentially 6 over 1 equals 7x minus 2. So just one more time, what method do I want you to use here? Well, yeah, we use quotient, but I'm saying to solve it from here on out, we want to cross multiply, right? This times this equals that times that. So we get 6 times x plus 5 equals 1 times 7x minus 2. Notice, like, past a certain point, these feel familiar because they actually work much the same way after a certain point. So this is 6x plus 30 equals 7x minus 2. So we're almost there. Let's move the 6x this way and add the 2 this way. So what you'll end up getting, these will be gone, and you'll end up getting 32 equals x. So before I circle it, I just need to go back and make sure I don't get what kind of log. A negative, right? That one's going to be fine. That one's going to be fine. I'm not going to get negatives either way. So it looks like my answer of 32 is legit, right? So I'll go ahead and circle it. So notice anytime we can, we're just rewriting the original, right? So that we can do a rewrite step in exponent form.